Hey, how's it going over on the YouTube side? Pradeep and Marco. Hopefully this stuff's useful. Marco, I also spent some time in Colorado. I was up there when I was in the Army many years ago. And then I have some friends that train Brazilian Jiu-Jitsu up there, so I do hang out with them sometimes. I need to check. It seems like my... Are these busted? Give me a second here. Don't worry, we're not doing the self-assessment today. I'm just checking why... There we go. Okay. Yeah, my stuff was busted. So, what are we doing today? That's always the question. Everybody's like, what are we doing around here, Scott? Well, today we're going to focus on networking a little bit because I tell people all the time, I've never done any Linux in my many years of doing this where the box wasn't on the network. So people always ask me, like, how much networking do I need to know? Well, you don't have to be an expert on the networking side of things from like the layer 3, how the devices talk to each other and that kind of stuff. You don't need to know all that, but you do need to know a fair amount of stuff. So we're going to go over some of that today. I figured I'd do a couple hours. I got some college students. I got to go. I do my study sessions on Fridays or on Saturdays. So I'll hang out with you guys for a couple hours probably and do this, and then we'll go from there. Boiled Spaghetti, thanks for the follow. Hopefully this stuff's useful to you. That's also one of the best names I've seen on here. I mean, I guess the only way I know to prepare spaghetti is boiling it, so that's a great name. But anyways, let's talk about our stream goals for today. So by the end of this stream, I think that you should understand some of the basics of IPv4 networking. We'll talk a little about IPv6 because that is there, but really IPv4 is still kind of the focus for a lot of networks. A lot of high performance compute is still run mainly on IPv4, as is most of your Kubernetes stuff, your back-end pods and your services and stuff. We're not going to go heavily into Kubernetes today. Maybe we'll do one of these sessions just on Kubernetes, but we're going to look just on a Linux box connected into a network. We're going to focus on that. So we're going to talk about the basics of that. We're going to talk about where your system configurations for networking are contained and how we can change that on a system. We have all kinds of reasons that we do change those and all kinds of considerations around that. Now, the focus of my last few talks have been on getting the job as an administrator, right? Because like most of us get into this field through administration of running networks and stuff that's already there. But I also want you guys, as we do any of this stuff, to be thinking about the engineering side, because you really do want to get over into engineering, because that's where, I mean, quite frankly, they pay you more over there, so that's kind of good. But a lot of these commands, I mean, it's not like there's a different command to do something as an engineer than an admin. They're still the same commands, right? So we're going to look at where things are configured, and that's going to be specifically for, in our case, a Rocky box. We'll be in Rocky 9.6. But RHEL flavors, RHEL is still, if I had to guess, Red Hat Enterprise Linux, RHEL, R-H-E-L. That is typically, I'd still put that up in like the 80th or maybe even 90th percentile of most high performance compute and most big government systems for sure that I work on. But even out in the enterprise, there's a lot of Red Hat Linux. So knowing the different flavors and variants that are out there is pretty valuable, I think. And then from there, after we look at how the system's configured, we're going to talk about the commands that'll view the networking state on the local box. And then we'll talk about commands that validate that we have the proper networking state by reaching out into the abyss, right? Like I always talk about, in engineering, when we draw something, and I don't want you to think about this part over here, I'll just draw it as a little cloud. And clouds in engineering are synonymous to some orthogonal thing that doesn't matter to what we're talking about right now. That's what that always means, right? So not that it's not important, it's just that we're reaching out into different systems and saying, okay, can I do this? Can I do that? So if you have a Linux, if you don't have a Linux box, if you're like, Scott, I'd like to follow along, but I don't have a Linux server to use, you can always jump into Killer Coda. So I will show you guys, let me pull up like Killer Coda here. You could always go into any of my scenarios if you wanted, but you can also go into just Killer Coda and hop into, let's just say, I'll give you guys a link to like one of my Linux labs. So looking around in Linux, this would be a perfectly fine one to do. I'm going to link this for anybody that wants it. I guess I can pin it. So there's the message if anybody wants to do it on the Twitch side. And then on the YouTube side, I think I can do a pin. Let's see. If not, I think I can just pin message. There we go. I do it a different way, but that should now be at the top. So, you know, if you're like, hey, Scott, I don't have a command terminal to get into right now, but I'd like to follow along, you can get in Killer Coda for free. I've never paid them any money. You can just go in here and be at a command prompt with me. There's a command I did earlier. And you see that you're on Ubuntu 2404. So some of the stuff will be a little different, but by and large, a lot of the stuff would still work. So, I mean, that'll at least give you something. Atticus, how's it going? Yeah, happy Easter. Yeah, happy Easter. We're celebrating. It's only Saturday here in the States. I know some of you guys are further along than us in the other side of the world, probably a little further along. But yeah, we're going to celebrate Easter tomorrow. My gym has a 6 a.m. wrestling session, so we're going to go in and wrestle, and then we'll hang out all day or whatever. So I think Killer Code is one of the best things on the web, because somebody came in the other day in the Discord, and I'm not trying to call anybody out, but they were like, hey, I don't have a lot of money, but I need to update my this and this and this. And it's like, hey, you can just if you've got a web browser to watch Twitch, you've got a web browser to go do Killer Coda, right? I mean, and all you need is an email, and I'm telling you, they don't even spam your email. Like, I've had them for a long time, and it's okay. Atticus, you're in the UK. Okay, yeah. Pradeep said I can SSH in my Ubuntu machine. Looking forward to following along. Awesome. Okay, so we're gonna focus on at first system configurations. Some of it will be specific to Red Hat Enterprise Linux, but then some of it will also just be generic against any kernel. So we'll look into that. All right. So let's get into it. And I have my notes here. If you guys want these, I'll take these notes and put them in the notes channel later. Let me plug our Discord a little bit. Discord's free, but one of the things I always try to show you guys is we have events coming up. So we've got a Bash study group today. I'm not 100% sure if that's going. That would be in an hour and a half for me. That's an hour and a half from now. I'm not 100% sure that's going because Kolkis was saying yesterday that he might not be around. So I'm hoping that he is, but because he had his days wrong. But he runs that. We're going to do our Linux group today, and actually we'll be in units 11 and 12 today. I forgot I'd never put out the discussions for 9 and 10, so I'm going to put out all the discussions here today, so you guys will have your discussions to go do. That's for the people doing the Linux admin course. That's free in the Discord. Linux from scratch is tomorrow at 3 p.m., and then I've put a placeholder for, if you guys have never done our Prolog annual conference, we're in our 12th year of running the professional Linux users group, and we have all kinds of different speakers coming in from all kinds of different industries around tech. I've got a, I've had chief engineers come in. I've had one of our guys is operations dude in the Space Force, and he comes in and talks about Red Hat Enterprise Linux security and stigging. So some of the same stuff that I teach you guys about stigs, he comes in and gives you some demos on it, and then he's got some pretty cool stuff he does. He's coming back to talk. He talked last year. One of my buddies that's an economist who's a chief, he's the chief, I think they call him a chief technical officer now at his company, which is kind of a smaller economics, and he does AI with his stuff. He's got some pretty cool projects I've actually looked at for him, and he just got his PhD the other day, so he's going to come in and talk to you guys and do all that. So these are all events coming up. This will get broken down into all the sessions when we get closer, but I just want it as a placeholder for people, because once you have this, I think you can download it as an event, and you can ICS files can be imported to your Google Calendar or your Yahoo, whatever you have as a calendar. Most people are probably using Google Calendar, but you can add that, so at least you remember that weekend we're just going to be hanging out talking the whole time. So come and sit in different sessions. My brother Tom is a data analytics guy. He's come and talked to the group a few times. I'll try to get him back out. And then I've got actually a couple of new speakers. One of our guys who did all the RHCSA study stuff. So if you guys are like, hey, I want to get an RHCSA, he's kind of got like a really good, he's got it up in here too, really good GitHub on setting up this RHCSA. But anyways, that's all in the Discord. So there's a lot going on, right? I mean, we got a lot going on. I want you guys to know that there's a place where you can go hang out. It's all free, right? Just hang out with everybody. We're approaching 5,000 people in there. We're at about 4,800 right now, so that's kind of cool. But it's a pretty good group, right? We've been running on Discord since 2019. So this will be 7 years on Discord, and what did I just show? Like 14 years of whatever it was. I forget. 12 years, did I say? Yeah, 12 years, and then 7 years on Discord. But we celebrate it all at the same time, so it'll be good. Lots of information about the industry, what's going on, all that kind of stuff. But again, if you guys need this information, I'll drop it in the notes channel after. but I'll just do it as raw notes so you don't have to worry about stuff. So let's talk about in a server, right? We're sitting at a command line, command prompt. We've dropped into a server. We knew enough to SSH into that server. We got that part down. But now, once we're in the server, maybe we're setting up the IP configurations, or we have a problem, or we're trying to validate where something was set up. Well, in a server like this, which happens to be Rocky 96, we're going to go down into etc sysconfig network-scripts. This is the location where RHEL pulls its configuration info from. Now, there is some information here. We're going to look at it, but let's go look at the default ifconfig, and this is the information that was generated in our cluster by Werewolf, right? And by the way, when you go to read a file, you can more it, you can less it, you can cat it, you can there's all kinds of things you can do to file. Sometimes I use more, sometimes you'll see me cat it. But this is the information that's populated in our system. So this is the way my system thinks it's configured. Now, there's also a README in here about ifconfigs, because Red Hat is moving away from that to mostly using the tool called NMCLI. And an MMCLI is really the way that they prefer that you look at the system and configure. And at the end of the day, though, a lot of that stuff just comes back and configures this. So it's kind of important to know. So we can say more on README, right? And then it'll tell us some information about Network Manager stores new network profiles in a key file format in etc Network Manager System Connections directory. Previously, Network Manager stored network pro. So I'll let you guys read that at your leisure, right? We're not going to sit around and listen to me read everything. But the point is, this is the config directory that RHEL has typically had. And then I'm probably missing some stuff. Happy Easter. Yeah, Easter's coming up. That's good. We're going to do, I was saying, we're going to be doing a little thing at my gym at 6 a.m. tomorrow so that we can do that before everybody has to spend time, gets to spend time with family, right? Me and the wife did a little thing yesterday. We walked around the youth set up this little activity thing at church, and you can walk all the way through from Palm Sunday through. It's all the different stages. It's kind of a fun little event that we did yesterday. So went with the in-laws over there. So okay, but yep, Ken, morning. I appreciate it. Any of you guys hanging out with me, just kind of working through stuff. We're taking our time because I have a little bit of time here, but I want to show you guys kind of what's going on inside the system. So we're here. We're in this directory, etc sysconfig network scripts. We can look around with ls, and then we can look at how our system thinks it's going to be configured. Now, this is important because I tell you guys often in the systems world, there's the way that a thing should be set, and then there's the way the thing's actually set, right? So we can compare this to some of these commands we're going to do in the next section, right? I started out by saying we're going to look at the config files, then we're going to view the actual networking state of this box. And sometimes the systems work that we do is simply, is this what I expect? Why is this server, in the military we used to call it, well, I guess the military way of calling it was fucking up by the numbers. Like, this server is just like categorically wrong on all these areas. Well, how would we know that? How would we know where the server was supposed to be configured versus where it actually is? So this is where it should be. There's also a whole bunch of stuff here. sysctl. Sysctl has all the kernel parameters that are tunable in your system. If you do a sysctl-a, and I'm just going to pipe it through a word count-l, there's 1,028 configurable parameters around my kernel that I could mess with right now in the system. We can change these. We can persistently change them by putting them in a file down in etc sysctl.d, and then when the system comes back up, the kernel will accept those new parameters, and it'll change the way that our system behaves. So let's do this real quick. Let's go look at this. So we'll pipe it through grep. Grep is our search function. And then we'll search for IPv4. And before I do that, I want to see, is that going to blow the screen up? That's 316, guys. That's a whole lot. So maybe I say grep for IPv4 as a filter. And I also want for us to grep for ICMP, which is the Internet Control Messaging Protocol. ICMP is mostly, from our system admin world, mostly tied to a tool called Ping, which is the Packet Internet Working Groper, which I think is a hilarious term because now you guys are all a bunch of pervs. You're out there groping on the network, right? But now here's all this. I knew there wasn't going to be as many of these. But did you guys know that you can change the behavior of a Linux box right here where it says ICMP echo ignore all? Did you know that we could ignore all echo requests that come into our system? Because ICMP for ping is echo request and I send an echo reply. Well, if I ignore all echoes, I'm no longer responding to ping. So if anybody ever tasks you in a company with turn off all the boxes, I don't want them to respond to ping. Now, I'm going to tell you something right now. The good idea fairy will come to managers and they'll be like, this is a great way to protect our network. We just won't respond to ping. There's like the good ideas that happen, and then there's actually what happens when the rubber meets the road. I want to be able to ping a box to make sure it's up, right? Like I've wanted that my whole career. A lot of tools use that. A lot of monitoring uses that. I would highly advise not turning this on, right? Because that's a 0 value. You turn it on to ignore. But you could. You absolutely could. You can go write it into a file. I could go like this right here. I can write this into a file, and this box will start to ignore. Well, on the next reboot it would, if it wasn't a stateless node. I can cd into etc sysctl, or some people call it sysctl .d, right? And in here, we can see what has been set in there. But I can just make another file in here, touch scott mods, you know, whatever, scottmods.conf. It's got to be a .conf, vi scottmods.conf, and I can drop that in there, and whoops, scottmods.conf in this directory. And when the system comes back up, if it wasn't a stateless node, if this were a persistent or a stateful node, this would then come up and it would accept that parameter. Now we can change that parameter live if we want to, and then we can cause the system to ignore pings live if we wanted to. What would prevent a ping flood, or does that not really happen? So here's the thing. Ping floods could still happen. Somebody could still ping everything in your network. This is just, at the end of the day, what this is logically doing is this box is like, I'm not responding. It's just sitting there like this, like, I'm not responding to any pings from you commoners. That's what this box is doing. You're not actually stopping anything. The traffic would still be hitting this box. Ping flood would still be able to, like, somebody could still nmap your network with pings and find what's going on, but this box wouldn't respond anymore. That's the only thing that would happen here. If they tried to establish an SSH connection on port 22, your box would still respond. This is only ICMP, only at layer 3 of the stack, and only for those types of messages. Now, let me show you guys something. This is kind of fun. This is way outside of what you need for networking on the Linux side, but I think this is valuable. You can go to ICMP Wikipedia, right? And you can go anywhere you want, but I think Wikipedia is fine for this. And you can find out about the Internet Control Messaging Protocol. This may blow up with white, so I apologize for how bright it's going to be. I'm not logged in, so I can't switch this to dark mode. But I wanted to show you guys, it's not just echo requests and echo replies. There is a whole slew of messages that Internet Control Messaging Protocol can send around a network. Right here, look at all these other, so typically echo reply and echo request. So there you go, boom, ping, respond. Those are the two that we play catch with in a network, right? But there's all these other ones. And your routers by default do want to tell people, I couldn't get to the source route. The destination port was unreached. Like, they're going to try to tell things about the system. And a lot of times we configure routers to not do that. Because why would I want my device telling you everything about what's going on inside of my network, right? So a lot of times we try to prevent that. So this is a thing to go read about. This is a little deeper than you need on the Linux side. If we're talking today strictly running Linux configurations and stuff, this is important. So now within sysctl, let me go here. You guys might say, Scott, what's the important things here? What are the things in here that are tied to like system configurations and security? I'm going to pull something up here called the Stig Viewer. The Stig Viewer is a free tool from the DoD. You guys can use it. I use it often in the government space for when I am hardening boxes. But I can come here like this, and I can go to my Red Hat Enterprise Linux 9 technical implementations. I can see there's 452. Now I'm on a slightly older version of this because I haven't done this in a while. But, also this one does have a dark mode. Let me go. I think I can go to... I'll go dark theme for you guys. But again, this is like the word dark theme. maybe the worst dark theme I've ever seen in my life, right? Thanks for the follow. Hopefully this stuff's useful to you. 1974, hopefully this is good. But what I want to show you guys is down here we can search, right? So I can search for, just the worst, sysctl. And here's all the ones that are tied directly to those sysctl or sysctl, people call it. Sysctl like that. Commands. So how might I harden some of this? So here's the problem. So here's always the discussion. What the problem is, we must restrict access to the kernel message buffer. We don't want other people to see it. So what I have to do is I have to turn kernel dmessage restrict equal to 1. And if it's not set, then that's missing or a finding, and I don't get to remove this secure technical implementation guideline or STIG from that configuration. So let's test this real quick. I'm going to do sysctl. I press up a million times to find it. And then right here, let's go kernel, and then grep-i for debug. Oops, was it not debug? Kernel's going to be a lot. Let's see what other things it was. It was, so I could just do dmessage restrict. Let's do this. Let's just do dmessage. So there it is. Now it is set to 0 in my system out of the box. So I am not adhering to this secure technical implementation guideline that would be valuable for me to harden the way that my system is configured to deal with, in this case, kernel. Now I want to filter this down more because we're talking about networking, not all sysctl. Remember I showed you guys that there was 1028 configurable parameters there? We want IPv4 for this. So here's the IPv4 ones. So determine if syn cookies are used, and then I can set the kernel perf event paranoid kernel parameter to be on. And then what will happen is there's a denial of service condition when a resource is not available for legitimate users. And if your system is accepting too many TCP SYN, SYN is, so it's SYN, SYNAC, ACK, that's the old SYNAC attacks. We can turn on TCP SYN cookies like this and to not, so it makes it paranoid. And what it'll do is it says that we don't allow too many open connections, basically what we call embryonic connections to the system. So let's go check that. Let's look for TCP SYN cookies. That is set by default as 1. So this would be a passing score for me right out of the box. Oops. Where'd that go? This one would be a passing score out of the box, which means that in general Linux is configured correctly. But hold on, if you said, hey, this server is my development environment, only we can get to it, and we want to test behaviors around SYNAC attacks, and we want to test buffers and this and this and this, and I'm going to go ahead and turn that off and let my box get overwhelmed with half-open connections, you can do that. Guys, this is your Linux box. You do whatever the hell you want to it, right? But I'm showing you guys where the configurations exist. And then if you say, Scott, I need to dig in and understand those configurations, this is where I would go read the STIG information. So in this one, ICMP redirect messages are used by routers to inform hosts. Well, my Linux boxes aren't going to pretend to be routers, so they're not going to accept redirects, right? So we want to make sure that that's turned off, right? But in some instances, and there's actually one here. Let's go find the one, accept source route, no. Martian packets, we accept packets that shouldn't belong, no. There's one here for redirects. No, that's filter. Yeah, right here, accept redirects. No, that's not right. Hold on, let's keep going. Source routed, no. Route packet filter. We can ignore broadcasts, so we don't want to allow broadcasts to the whole network. We won't respond to them. It'll still happen. All right, this is send redirect. So this is, no, that's not it either. Hold on, where is it? So these are all CMP based. Here's the one. If rel is not performing packet forwarding, so this is one that we almost always universally turn off. In fact, this should probably be off. Let's go look for forwarding real quick. Forwarding is off on my box. Why is forwarding off? Well, because the server's not a router. Can a Linux box that's on multiple interfaces with routing set in the kernel function as a router? Absolutely. We used to route. I have a router in my home lab. I showed it to you guys a few weeks ago. In fact, this is it right here. So this box is actually set to forward. C router. I know it's hard to read. you can't get into it remotely. I only allow console access to this guy. So this one's a little messy. Let's look for forward. This guy allows forwarding all over the place. ICMP, IPv4 conf, all forwarding is equal to 1 in this box. But in a general Linux box that's not functioning as a router, that's all off. Look at this. As it should be, because the box isn't a router. But can a router, or can a Linux box be a router? That kernel is perfectly capable of routing traffic all through interfaces, yes. So, do I do Active Directory hardening? I don't do AD. I don't do, well, let me say it like this. I haven't been a Windows admin strictly a Windows admin for probably about 20 years. But I was the lead on a team where I was over about 3,500 Windows servers years ago. That probably ended in 2023 or so. So I do know some Windows, but no, I haven't really hardened Active Directory ever. But I do interact with LDAP often for my systems to be able to accept users and trust and that kind of stuff. But I don't do Active Directly anymore. And I don't think there's any Windows stuff on my resume at all. Like, I don't even tell people I ever did Windows for the most part. But you know, at least on the technical side. But hey, how's it going, guys? Julius Caesar over on the YouTube side, and Dippy, thanks for hanging out. We're looking through. I've got a set of goals for us here, and we're down in system configurations right now. So system configurations, we started with the networking, and then we moved over to system cuddle, or sysctl, whatever you want to call it. Guys, you'll find that I'm not super. I know a lot of engineers that like to force people to say things a certain way or talk a certain way. I'm like, well, I know what you meant. I think you know what you meant, and that's what I care about. I don't care if you're like rigorously following all this stuff the same way. All right, so I'm not overly, and if I sound like I'm overly pedantic, that's only because like I sometimes explain this to you guys where sometimes this is the only time you get to talk tech with people. You know, maybe you break rocks all day, and then you want to come in and hang out and, you know, talk more shop and hear how engineers talk. So then I do that for you guys. So, all right, and thanks for the follow, The Engineer. That's a great name. Anyway, so yeah, so we can check all these things. Man, there's so much stuff. And what I would do is like check for IPv4. Word count -L just so it doesn't pop up on the screen. Let's see how much IPv6 there is. So there's 296 of those, but we can still pipe it through more and go look at them. Here's all the IPv6 stuff that's going on, right? There's a lot of IPv6 that our kernel can handle, even if we're not using IPv6 in our network, which is actually a thing that we might want to validate is, and we'll do it in the next part where we look at the state of the system, is how is our system, what was our system doing? How is it talking in the network? And all of these different values relate to, in this case, the Ethernet 0 interface and how it's going to be directly dealing with things that are going on in IPv6. Hey, Paul, how's it going? If you guys don't know, I've known Paul for the better part of 13 years or so. Paul, but you moved up to Idaho, so I don't see you as much anymore. But yeah, Paul used to ride by my house all the time on his bike, on his long, 30-mile bike treks and stuff. So anyway, so we're looking at, again, this is our main goals for today, is where's your system configurations, where are the networking components defined, and we're looking at sysctl kernel parameters right now. Then we're going to go in after this to looking at the networking state on this box, and then we're going to look at reaching out into the network and validating that we can interact with the network the correct way. So now the next part of this is, again, just for configuration standards, maybe we have a standard in the company that, or a standard from a STIG. The two major configuration standards that you're going to baseline, what we call baselining the system, or some people call these benchmarks, is Secure Technical Implementation Guidelines or the CIS benchmarks. And you can go get the CIS benchmarks off the internet for free, but you do have to give them your email. It's from the CIS. CIS is NIST, I think, but it's Center for Internet Security. And then STIGs come directly from the DoD, Department of Defense, so you can download those. You haven't rode all year, Paul? Oh, wow. Paul, they keep trying to get me to buy, on social media, once you talk about something, they're trying to get me to buy these little bike things that you kind of stand on and ride, and then they are, and then you lean. And I told the wife, I was like, they look really cool, but they're $995 each. And I'm like, I mean, that's That's a bit much just to kind of like ride a bike. That's kind of a bit, yeah. 35 this morning, geez. It was 69 in Phoenix, I think, this morning. So that's kind of cool. Liebeck said this is a bit off topic, but wouldn't you want demessage to troubleshoot if something goes wrong with driver kernel? Yeah, demessage is fine. Yeah, especially demessage is especially useful if you're booting servers and something's not coming up. So I can do demessage grep for error. I'm not necessarily right now, or in this case, like let's say ETH, I wanted to see that my Ethernet driver had booted and working. And it looks like my Ethernet driver, when my system was first starting, and actually maybe it's still doing it, it's been going in and out of promiscuous mode. Something's been happening to make my Ethernet behave that way, and I might have to go figure out what's going on with that, right? Yeah, demessage is fantastic for troubleshooting. I'm just strictly right now showing you guys configurations. Troubleshooting will be that third thing we do when we get to like reaching out to the network. But yeah, demessage can show you a lot of stuff. The other one might be lsmod to see what kernel modules are loaded. Maybe I know that it's virtual IO, so maybe virt IO, and then I look to see if any of these drivers are there. Or maybe I look for like ETH, or maybe I look for net, right? And I just see what kind of net stuff is showing up. virt.io net is there and doesn't have any anything that's depending on it right now. But NF tables are there. NF tables are filters, which are kind of going to be one of the next things we kind of look at in this environment. So systemd, all right, so back up a little bit. This is all routing, and this is all stuff that happens within the kernel, and we were just looking at all those kernel parameters, right? But then there's a bunch of filters that can happen as well, and we used to use the old IP tables. IP tables was the command to do filtering for the kernel. But we've moved away from IP tables in modern Linux. I want to say for sure RHEL 9 and on uses it. I think 8 was kind of switching. Now we use a thing called NF tables. But we don't tend to do so with IP tables. We used to do IP tables -L and see all the configurations, and then we could add kernel filters in there, and they affected the way that our system accepted packets and frames and forwarded them, all kinds of stuff. And that was really how we turned our box into a filtering router, right? Now with NF tables, I don't interact with NF tables directly anymore. I typically only touch them through Firewall D. And then Firewall D, you've got a firewall-cmd command that will allow you to mess with it. So let's check to see if a firewall's on in the system. Firewall D is running in our box. Okay, so now if Firewall D is running, that means that there's a set of filters that are happening over the top, and these are NF-based filters, so it's NF tables-based filters in my environment. So how do we look at those? Firewall-cmd, and you can run help if you need, and it'll give you a bunch of information about it. And I almost always have to look this up because I forget. There's all kinds of services and other stuff going on. And then what I might do is like get all the zones, right? I wanted to get the zones. So here's get zones as a command. And there's the zones that are there. And I can get services. Now services are all the services that are available. Let's go up and look a little more. We can see what the actual setting of the current system is. We can see what the default zone is. So we can get default zone, right? Boom, get default zone. That's public. So here's our public zone right here. And here's all the things, but these aren't all configured. There's just what's there. And then I can see what's actually there. By the way, we can reload, we can do all kinds of stuff. We can set things permanent, which will go affect the actual configurations. But let's, so we get zones. We should be able to load, we can list all zones, list everything added or enabled in the zones. I want to, where is my, yeah, we'll list all zones, that's fine. And this will pull up, and now we know that we're on the public zone, so these are the other ones that show what's going on. But here in our public zone, we have cockpit, DHCP v6 client, and oh, we've got a Prometheus node exporter that's allowed. That's going to be important in a second here, and SSH. So in the public zone, which is active on our interface ETH0, which is our interface we're going to use later, we've got these services allowed. Okay, well, that's interesting. We can go look at how these services are configured. We can do that a couple ways. We can do it through here, or we can actually go into where, yeah, in Firewall D, here's our services. And I can go look at the services. By the way, we can build our own services. Once you see one of these, you're going to go, that's all it is. It's this easy. Watch. Let's more SSH. D. SSH.xml, sorry. And this is how the XML is configured. As with all markup languages, you just turn them on and then you turn them off. So here is the definition for a service. And then you're in the room service, and here you close the door on the room service. So you go in, do your whatever your service is, and then you exit out. So here's the full definition of a service. Here is the short definition of it right here, which is SSH. That's how it's configured to show up inside of Firewall D. And here's the end of that. Then here's the description, short description, and then there's the end of the description right here. XML is pretty straightforward. Now, this is where XML and HTML will throw you for a loop if you're not familiar with it. This is both a definition. So this is what we typically call these tags or labels. Here's the start of one for port, but then instead of having a closing port, we close it within the same tag definition, and then we give multiple values inside of it. That's all this is. This could truly have been port protocol equals TCP, and then close port protocol. And then on a new line, port 22, and then close that out as well. But see how the shorthand's a little more clean than doing like 2 lines like this and then adding more and more. So I'm not trying to make you an XML master. Go play with it if you want. But you can add definitions. So if I had a second version of SSH that I needed to add to the server for, I needed to have like maybe I wanted SSH on port 15,000, and then I was going to run a second SSH daemon so that I could get in even if users had clogged stuff up. This is very common for like login nodes and high performance compute. We'll have a second SSH kernel to allow us to drop in even if all the users are basically like stuffed in and they've clogged up the first SSH session. So now we can get in without having to go all the way down to the console. There's a bunch of different ways to do this, guys, but I would just come in here and I would copy this. I would put in a file called like SSH2, and then I would change the name here to like SSH2, and I would just change the port number to the port that I wanted. That's all I'd have to change. It would be that easy to just set it up. And then so that's where those configurations are if you need them for a firewall. User lib firewall D services, and all of them are XML configurations in here. So let's go check something real quick. This is going to come up in a second here, but SSNTULP, we're going to grep-IE, so we're going to do extended grep, so that'll allow us to filter, and we're going to look for 2 things. We're going to look for node and SSH. You say, why node and SSH? Well, because I want to show you something. SSH I knew was going to be on port 22 because I'm very brilliant. No, it's just the default, right? It's not that I'm brilliant. It's just that 22 is the default for that. And we listen on any port. That's how we see any incoming port. So we're listening on port 22, but we're also allowing port 22 on that public Ethernet. So public Ethernet 2, that's our firewall. And we allow SSH on port 22 right here into our system. Okay. Everything's connected. SSH should work. I can get into this server on SSH. Well, we know that because we're in there. But that's how that's all, like, if you want to think of it as like plumbed up, that's how we know that everything works all the way through. But hold on a second. This server, Rocky4, also is listening on port 9100 for the node exporter. Now, I told you guys a second ago right here, and not everybody probably remembers it, Prometheus node exporter is set to be allowed. I had to allow port, well, we hope, 9100. So could I say, in this thing, can I say more Prometheus node exporter? And could we surmise, could we guess that definition is going to have 9100 in it? What do you guys think? Do you think it's probably going to be there? Yeah. Because at the end, there it is, 9100. Because, like, look, I tell you guys all the time, I'm either sitting over here casting spells, or it's all chutes and ladders and everything points to something else and it's actual engineering. I tell my college students a lot, this is auto-magically happening. But then once I show them how it works, or once we get to that module and I kind of demystify it for them, I never refer to it as magic again. And there's that old saying, it was, I always think it was Albert Camus, but it wasn't him. Who was that guy? And I think Richard Stallman, and it wasn't him either. There's a famous quote where he says, Arthur C. Clarke, that's his name. He was a writer, a sci-fi writer in like the early, I think he was in the 60s and 70s. And he used to say, any future enough technology is indistinguishable from magic. And that's why I tell people, like, when you watch like sci-fi or something and they do something that's like magical, but they never explain it, it's like, this is not a sci-fi show, it's now magic. If they try to explain it in some way, then it's still technical, right? But once you just say, it just happens, we just beam people down to the planet, you're like, all right, well, that's magic then. Anyways, all right, we're not getting into all that because I'll piss off the nerds. But 9100, and it's passing through 9100. So, interestingly enough, we could look at that service if we want. But if we're on our own server, your system itself bypasses the firewall. So I could always check that itself. But what I can do is I can bounce out of the server real quick to Werewolf. And let's go look at that. That port 9100 should be open on this. So I can do a couple things. And we're going to see this in a little bit. Netcat VZ, Rocky 4, and then port 9100. And I should see that it received and connected on port 9100. Well, what if I told you guys that the Prometheus node exporter is, you guys are going to be like, man, that's it? This isn't super brilliant. Prometheus just comes along and scrapes any nodes that's configured in it. So any nodes you configure on whatever port you want, it'll go and scrape on its either default in this case or any other port you want, because you can write your own exporters. But look, this is the whole thing it's going to do. I'm just going to curl over to Rocky 4 on port 9100, and then I'm going to go to the metrics, because metrics is the actual path that's exporting. And this is going to blow my screen up with a bunch of key value pairs, and those key value pairs are being fed into Prometheus, and then they're being presented by Grafana, and then because of that they're coming up on my screen over here. Some of you guys have been here when I was here. They're right here. So Rocky 4 is being scraped by Prometheus. Actually Rocky 4 is just open. He's not actually, I don't have him in the configs, so don't worry about all that. That's just me in my home lab being lazy. Rocky 4 is like my test version of stuff, so he doesn't make it in all the, I don't get him in all the monitoring. All the other monitoring servers though, that's how all the monitoring happens. You said, yeah, it's easy to enjoy setting environments at very granular levels to do peculiar things. Yeah, fair enough. So I just want you guys to see, here's your system configurations. Etsy sysconfig network scripts, that's where traditionally things have been pulled from inside of the RHEL systems. And then in here, there's now the README where things that you're doing are going to also be controlled by Network Manager. I'm going to tell you, as a professional, I almost always turn off Network Manager. It just causes me so much headache. It rewrites your DNS configs. It does things that I just don't like for stability reasons. So I've always turned it off. But it looks like they really want you to use that more now. So I don't know. It's up to you. You have to kind of look at the behavior of it and see if it's something that's interesting to you to use. But anyway, so those are our system configurations. We just went through all of those and the different ways that we might configure things. So let's go back over here real quick then, and let's go to our next part, which is going to be commands to view the current networking state. So I'm on a Linux box, right? You're not, look, if there's a problem in the middle of the night, you're not going to go look at all that config stuff. The configs are probably right. I mean, as long as nobody's been changing them. I mean, nobody should be changing that stuff in the middle of the night. And if a server reboots or something, that's much less interesting to go down there unless something's like dramatically wrong with it. These commands are probably what you're going to do to kind of check the state of the network as it is in real time. So we're going to do stuff like IP adder. IP adder will give you, it's short for IP address, it will give you the two interfaces in this case that I have on this device. I have a loopback interface. All TCP IP connected systems have a loopback interface. They always do. And this one here is on port 127001, which a lot of us nerds tend to call home. That's home, right? There's little shirts that say there's no place like 127001. They're being very clever, right? No place like home. That's all they're doing. And then they're patting themselves on the back. That's what that is. Love me some NetPlan. Yeah, NetPlan is definitely going to be for you guys that are using Ubuntu. NetPlan apply and all that good stuff. But now we can see a bunch of stuff about the network. In a loopback interface, my maximum transmission unit is 65,536. Now, that's not a made-up number. That is 2 to the power of 16 right there. And that is all the definable states of nature for it, because normally the numbers you see is 0 to 65,535, because we start counting at 0. That's showing you that it's all the bits. So it's 1 to 65,536 is how they're counting. They're not including 0. There's some other information about it, not super useful or necessary for us here. But then now, when we look at the loopback interface here, we also see IPv4 address that we just talked about. And then we also see the loopback for IPv6. So the IPv6 loopback address is : : 1. That's always going to be there. This is going to be useful for when you look at listening addresses later. What are we listening to? And what you listen to, especially for when you lock a box down with secure technical implementation guidelines, sometimes services should only be listened to by the local host. You're not listening to other traffic. So that's good. So loopback interface is very important. You know, I can just ping 127.0.0.1, and maybe I do like a C5 or something so it doesn't go forever. And this just validates to me that my NIC is working within my system. So my network interface card is working, right? It's not a NIC card, by the way. This is a virtual machine, so I don't have a NIC to go look at to see if it's green or orange or whatever, or blinking different on the back. By the way, I'm colorblind, so I tell people, like, when I look down a row of servers, I can't always tell if they're like a light green or a shade of orange, but I can tell when things are blinking differently. Like, all my servers are blinking down, but one is like a steady, probably red or orange. I can see that right away because the blinking is differently. So I look for the blinking patterns. I don't see the colors right. I never have. Right? Pretty much blind in that regard. But then we've got our Ethernet interface over here, and our Ethernet interface is responding. We see it, so this is important. And we've got a maximum transmission unit of 1500. That's the default maximum transmission unit for an Ethernet 2 frame, so that's good to know. However, there are also jumbo frames, which can be 9,000, and we can also configure them up to like 65,000. But we don't need that in most Ethernet networks, so 1500's there. And then we can see some other stuff about it that's useful. We can see its MAC address. MAC address is your burned-in 48-bit address that is, well, in virtual space, it's just arbitrarily defined. But in physical space, those MAC addresses can be triggered back to the first 24 bits are the hardware vendor, and the last 24 bits are the product, which is just, you know, generic. Let me go prove that to you, right? Let's go to a Windows box real quick. Let's go to my home box here. And just a little home server here. We'll do a little bit of stuff. I'm going to do ipconfig all. And I'm just going to go to my wireless LAN. And I'm going to take this physical address right here. I'm going to Control-C it, right? And I'm going to go to a web page here. And I'm going to say, like, MAC address find, right? Something like this. And here's a MAC address lookup. And I can just drop a MAC address in here and hit search. And it should tell you, well, let's get out of here. Come on. They're trying to sell me cars and stuff. I don't need any of that stuff. And it should tell me vendor was from Intel Corporate. So I know that. From the first part, look, it's looking at the first. And you might say, how do you know that that's 24 and 24? Well, it's 48 total, so half and half. But also, each hexadecimal bit represents, or each hexadecimal number represents 4 bits, right? So that's 4, that's 4, that's 4, that's 4, that's 4, and that's 4. So that's 24 bits right there, right? And you know, and then you could break them down further if you need to, right? You can actually break these back down to the individual binary if you need to, but we don't need to do that right now. But I just wanted to show you that, yeah, that is an Intel wireless card. I see it right there, but I also could go find it by those first 24 bits, right? These have to be what we call locally unique on a network. They can't conflict locally. Universally, so an Ethernet frame never leaves the next hop. I don't know if you guys know that, but an Ethernet frame never leaves the next hop, so this is never seen by anything past the next hop. And it's kind of interesting. Like you'll watch. I've seen this before. I remember for sure Criminal Minds did it with that kind of heavy set super technology chick or whatever that they had that's always solving everything immediately. She's like, I tracked them back by their MAC addresses, and you're like, no, you didn't. Like, it never left the hop inside of their device. You could have tracked their external router, but the next hop, it's gone, right? So MAC addresses aren't logical and they don't go anywhere. It's like a short name. Like, my name is Scott, but that doesn't tell you where I live physically. You have to have my actual address to know where I live, right? So MAC addresses are much less useful, but they love to say that on crime shows, and then you just giggle because you know better. It is short name ETH0. That's very common in RHEL environments. We try to that's been a standard every time I've ever used RHEL anywhere. We try to just turn it to ETH0. But there are alt names, and these are the names that come typically from the original setup of the system. And all of these tend to be searchable as the system first comes up. So I could probably demessage grep for any of those, right? Or, that's an OR, right? That filter there is now an OR. And we say ENS 18 or ETH0. And what you'll actually probably see is the system originally come up with one of those names and then flip to an alias. That's almost always what you see. We just see it ETH0 because these are the command line calls right here. And then there's the interface name ETH0 as it first sets up. It gets DHCP. Oh, actually, you know what? Yeah, because the system originally comes up with DHCP and then it pulls its config down. I just don't know what these later ones are, why it's entered, and maybe I was doing something funky with the box, I don't remember. Because this is the second since the kernel's been up, right? Yeah, I don't know what this box was doing with those, but all right, doesn't matter. Let's go back here. IP ADDR, or IPA as some people like to do it, is okay, right? It's got some good info. Also, my Ethernet interface has an INET6 address. So we can do IPv6 networking with this box if we want to. It is what we might call like a dual honed, or some people call it dual stack, IPv4 and IPv6 enabled system. But that doesn't mean that it's able to route IPv6 because I don't have IPv6 set on the C router, so we couldn't do IPv6 routing if we wanted to because of the limitations of the network that I've done that on purpose so that only IPv4 traffic can leave this network, right? I didn't want anybody doing anything funky in the network, so because I expose this for anybody that wants to use it from our Discord, so all these Rocky servers are out there for you guys to use. All right, so anyways, that's cool, right? But I prefer, when I'm just like doing a quick check on a box, I prefer this one. IP-BR ADDR. It's just brief now. Doesn't give me all that other info. I don't care. Maybe if I'm just looking real quick for like high level differences between systems and I just want to compare them quickly, that's a more brief. I think that's for brief, the BR, and it shortens it. You can also do, some people really like this, dash cap C, I think. Maybe it's lowercase c. And this one does, I don't even see a difference. I think it's maybe defaulted. I think that's the one that gives you color, but we can man it and figure it out if we wanted to. But I don't really care about it. I've seen a lot of guys use dash C. I prefer the dash BR though, right? And it depends what you want to see. So, all right, so good. So we can do IP-BR ADDR, and then now we can look at the network from a perspective of what routes we have. So we can do IPR, or we can do route, and it'll tell us the routing table that our system is going to use to get traffic out of this device. So we have a bunch of values here that we can then go figure out. Now this is where it gets, I'm going to do some real networking light stuff for you guys. Some of you guys have been around and seen me like break down IPv4 addresses for you and stuff. If you want me to do that sometime, we'll do that separate. But really quick, just to kind of give the highest level overview of that I can, this /24 right here means that the mask is 255.255.255.0. And what that means is these /24 are the network bits, or for the purpose of route calculation, the significant bits. Don't worry about anything I just said. 24 matches the first, there's 8, 16, 24 bits. So the first 24 bits are significant and matched because they're the network. Okay, so what I mean by that is if I went to host www.google.com real quick, and I saw that he was on 142.251.157.119, I would do a very silly thing here. We're going to AND the bits between these to figure out what's on the network and what's not. So 192, and without getting into the math of ANDing, they have to match. So the first 24 bits here, 192.168.11, I'm about to say something very silly, does that match exactly 142.251.157? So this is not the route that is going to pick if my system wants to send to 142.251.157.119. Can't do it. Also, it's really funny how this thing just can't. This thing right here just can't keep up with any when we get into engineering talk. Just not doing anything. So now this one, 192.168.200, we're going to say something very silly. Does that match 142.251.157? No, not even close. So what we see here then is our routing table is a big fat failure. Our routing table can't get to that. So if, by the way, if you don't have a default route, do you guys know what routers and Linux boxes do if they're trying to hot potato a packet and they don't know what to do with it? They frickin' drop it on the floor, guys. They just drop it. They said, not my problem, not in my routing table. But if we have a default route, the default route is the catch-all. It's the else statement in an if-then else. It's an else. It's a catch-all for everything else, or in a case statement when you do an asterisk at the bottom and you say everything else. You made it through all these decisions and didn't get it, you're going to fall into that last one. Well, if you fall into the last one, we send you to 192.168.200.1 on ETH0. Now, you might say very astutely, well, Scott, it wasn't this one, but it was going to go out ETH0 and it was going to go out ETH0 and it ended up going out ETH0, so you're a dummy. It just took longer to get there. And I say, you're right, maybe. But the point is not the fact that it took the same path, it's how the decision made it to that path. Because again, if we had, this is super simple values, but if we had a Linux box functioning there with multiple paths out of it, it's gonna make decisions based on what we call the shortest prefix match, but it's really a network match of however many bits we have. So let's go look at I'm gonna jump to a different part of my network to show you guys this. Here's my original jump box. We're on hostbox, so let's jump to my original jump box. And let's look at his in my home lab. So there's his interfaces. Oh, he's got a whole bunch of other stuff going on. And now he's got all kinds of different ways to get to all kinds of different networks, right? And then maybe I say, maybe I want to ping here in my network. I want to ping, let's go 192.168.200.25. Okay. So we were able to ping that 192.168.200.25, but how did we get to this network? How did my system know to get over there? Well, let's go look here. Was it matched at the first only there's 16 bits, so only the first 2 octets? Does 192.168 match 169.250? No, it wasn't this one. How about 172.17? That's matched at 16 bits. Does that match that? No. 192.168.11, because that's /24. That got close, but that doesn't match, so it wasn't that route. And then 192.168.122. Nope, it doesn't match that either. So this had to go out my default, so I had to go default to 192.168.11.1, and then it got redirected from there. That actually sent a redirect to go to 192.168.11.160. Why the heck did it go over there? That doesn't make any sense. Unless you know that in my home lab, that is this interface. And this is hard to see, but maybe I can full screen just so you guys can see that. 192.168.11.160 over here. And then on the inside of the other interface, on the 192.168.200.1, he's the routed interface for the default routes on the boxes on the other side. So watch this. Pull this back up. Here he is on this side. The traffic is coming 192.168.11.160 to him. But if I go back over here, remember his default gateway was 192.168.200.1. The boxes inside of the 200 network, which is my lab network, they use his interface, and then that box routes between the two networks. 192.168.200.1, 192.168. So this thing can route between these two interfaces. That's what it's doing. All right, we're not necessarily getting into turning Linux boxes into routers, but if anybody ever needs to do that for some very specific reason, in my home lab, the very specific reason I have them on different networks is because I run 2 different VLANs in my home environment, and the reason I have to run 2 different VLANs is so that I can run DHCP in 2 different, because DHCP doesn't span network boundaries, but it does span. I mean, everything in one VLAN is going to see DHCP because it's broadcast at the MAC layer, right? So you have to split your VLAN so that you can run Werewolf in one place and then normal networking, right? Because like, what would happen is in my home lab, I would have to turn off DHCP, and then people would come over and ask to get on my network, and they wouldn't get a DHCP address, and then they'd be pissed, and they would never come over again. Or my kid's tablet wouldn't work, or my wife wouldn't be able to get on, whatever, or my IPTV downstairs that wants to connect in and do Netflix and stuff can't do any of those things because it doesn't, when it first comes up, it doesn't get an address. So, all right, it's all just... This is why we separate things out, so things can exist in their own areas. But all right, so we're just looking at what's going on inside of a server, right? And we did IP adder, IPA, IPBRA, right? Or ADDR, whatever you want. You can do that all kinds of different ways. IP route, we got into routes, and we talked about kind of how that routing goes. And if you want to dig more into that, just let me know down in Discord, and I'll do a topic on that again one day. But next one is NMCLI. So NMCLI by itself will just give you a bunch of information about the system. But what I tend to do is use NMCLI con show, and this will show me the connected interfaces, right? And then I can start to dig in on, I think I can say con show eth0. You might have to use different thing. Let's do this, and then it should give me help on that. Yeah, you can turn things on or up or down. I mostly just use con show when I have multiple interfaces on there. But real quick, look at this. It's got all that same stuff that we saw from the other commands, just in a different way to look at it. Right, you can see what's there. If I had more interfaces, then I would be able to see them. Oh, device show, that's what it is. We can also do device show, and then that'll dump all of the configurations and tags for, in this case, eth0. And now I can start to add more and more to these, and I can get more and more to this. So there's actually some interesting things that happen here as far as our gateway, having a gateway set in our environment. Because when I first set up these little Werewolf boxes, they didn't get a default gateway. So we populate the route default right here. That's auto-generated by Werewolf and pushed down to all of my different nodes in my lab cluster. That's not that interesting to what we're talking about here. I really just want you guys to have a tool to be able to see the state of the network. And then you might look at it and go, well, this box isn't supposed to be 192.168.200.254. In my diagram, this box is supposed to be something else. And you might say, Scott, would you ever really see that? I've actually seen that before, where decommissioned servers were taken offline and then they're sat for like 3 weeks a lot of times out in the industry. That's going to be based on whatever your company wants to do. Also, Reed Cyber Ready, hi chat, how's it going? Hopefully this stuff's useful to you. I am kind of paying attention down in chat when I do get a chance. I'm just kind of brain dumping on you guys. You guys get to see what my college students see, because this is what I like when I just brain dump and kind of flow through stuff. Where I was going with this, I've actually seen this before, where boxes are sat in a decommissioned state. So when we leave them in a decommissioned state, they've got all their configurations, but they're ready to go to like a later stage where we actually delete the data off them. And what happens then is, and I've seen this before, where the IPMI, or the IPAM, what we call it, IP address management, will then take that number out. That'll be part of our decommissioning steps out of service now. Maybe we even automate it, and it clears that IP address to be grabbed by another server. Because mostly in the industry, you're not using DHCP on servers. Servers get static addresses that are assigned to them and typically then maintained by DNS through like an IPAM tool or something. That's IP address management. There's what is it, like I think Bluehost or something like that. There's a few different ones, but they're just IPAMs, IP address management. And then oh good, right, Reed. Yeah, if it's all following along in your instance. Yeah, I'm just kind of flowing and showing you guys things that I think are useful as an admin to go see, because at the end of the day, I tell you guys this all the time, you're just looking into an abyss, right? You need to know the commands that'll show you what's going on in the system, right? All right, so and then NMCLI by itself will just kind of dump a bunch of info for you. And then where I was going, it's okay, so then somebody will be like, oh wait, we need that server back up to get some data off it, and they'll bring that server back up, and now you've got conflicting IPs. So then when you SSH in, you get to the wrong server, and you're like, wait a minute, why is this server having intermittent, like, transient errors on the network and this, and then you realize two things have the same IP, and then you realize one of those servers was brought back up so somebody could grab some config off it or something, but nobody ever turned it back off, and then it's like, because guys, honestly, like most mistakes that happen in companies are because there's too many cooks in the kitchen. I had a buddy, one of my cybersecurity buddies, he's down in our server, his name's Faint Calf in there, and the way he got that name Faint Calf is actually hilarious, but we would have like some kind of problem happening in our environment, and he was the security guy, so he'd be looking at security stuff, he'd be going looking for rogue access points, and we would be sitting there and he'd just be humming and I'm like, what the hell, one day I asked him, what are you singing? And he's like, oh, Too Many Cooks. And he'd be singing the song, too many cooks, and that's just this little song that he had. And then too many cooks in the kitchen, too many people spoil the broth or whatever, that's the saying. But he'd just be laughing at us because we'd be troubleshooting stuff and looking at stuff and whatever. And then there's an old God, what is that show? I don't even know what show did that skit. But if you want to go look up something that's pretty what we call unhinged or tilted or cursed, go look up Too Many Cooks on YouTube. There's a video that'll just keep going and keep getting weirder, and it's actually pretty funny. Yeah, and Too Many Cooks not talking to each other for sure. Yeah, you need communication between systems. And there's a really funny show that actually really held up from the 90s called Frasier. If you guys ever get a chance to watch Frasier, it is absolutely hilarious. Because him and his brother are like, they're basically shown to be like the two smartest guys around. They're both psychologists, but they're flipping idiots. The two of them, and it's Kelsey Grammer, who's already a funny guy because he's like a straight man, but just like, and when I say straight man, I mean like he doesn't seem like he's like telling jokes, but he is. And him and his brother buy a restaurant, and basically they keep going in and tasting the soup and changing it, and they ruin this and they burn the restaurant down. It's just funny. It's like all the weird scenarios they get in because they're like almost too smart for their own good, but they always get in stupid scenarios. Fantastic show if you ever get a chance. I think it's on Netflix or Hulu or something. But all right, so let's go back then. We talked about IP adder, we talked about IP route, we talked about NMCLI. Let's talk about ETH tool. ETH tool, ETH0, has this really awesome, this is one of the most useful things I've ever gotten into, because this is a virtual machine. Rocky 4 only exists in the memory of this server right here. There's no physical box for me to go into a data center anymore. I used to go in data centers and I would have to like look down the row and see if the cable was actually up and if it was plugged in at the other side to either a patch panel or switch or whatever. But it was very easy. Like the port's down, it's not even on, even though you got a cable connected into it. Well, this box only exists right here. So, I mean, it says there's a network device right here. I see a network 0, but there's no physical place for me to go look that Rocky 4 exists in my environment. There's nowhere to go look. So how do you know that the server is seeing that the hardware has been presented to it? And that's the command ETH tool. ETH tool will show you the link is detected. Yes, this is one of the most useful things to know, because all that other stuff that I just showed and all these other commands to see how the network's set will be busted if the network connection is not up. You'll get all kinds of other errors in this world. but this is a super useful one. But I didn't show it first. You say, well, why didn't you show that first if it's the most useful? Because normally if you go to a box, first, if you SSH into it, you know its IP is working. If you do that, you know that the Ethernet's connected. You don't have to go check. This is when I tell you guys troubleshooting and we walk through the OSI model. If I can ping a box, I don't have to go make sure the box is on. However, like I said, sometimes somebody's turned on a server and has an IP, and there can be weird situations when there's too many admins in an environment, which is why we control things with an iron fist, which is why we actually respect, normally I wouldn't respect configuration management people. I'd be like, this is wild, wild west. I'll do whatever I want as the admin, right? I'm root. But to make our lives easier, because everybody would be thinking like that, then we'd just be having gunfights in the street and our server and our uptime would be suffering. So anyways, where I'm going with that is ETH-Tool is a fantastic tool for this. There's also a few other things that are useful. Now in this case, speed and duplex are unknown, but it's because it's coming off a virtual machine, and I'm okay with that. But very often, and I don't have authorization from work to hop into our work lab environment, but if I did, I've never even asked for it. Maybe I can ask for it one day. I could show you that one of the things that we do very much with Ethernet and also with a tool called InfiniBand, because InfiniBand ETH-Tool will also work with it, we can see there's a separation of two things that we can see. All of the speeds that this interface is allowed to configure, because a lot of times when you're using like Mellanox ConnectX cards, which is Mellanox is owned by NVIDIA, so they're all the fast high-speed network, you'll have like 30 different speeds that this system could run if this ConnectX card is connected into with an SFP fiber from whatever InfiniBand connectors you're using, right? Now hold on. But then there's another value right here, which is, and auto negotiation's off, but it would have all the speeds, and then it would have the actual speed that we are set on. So I expect like an HDR InfiniBand link to be 200 or 400 gigabits per second into my box. But if I don't have that, or if I only have a single channel, like sometimes we'll have two channel paths coming into InfiniBand, if one of them's down, I'll still be experiencing 200 gigabits per second. And some of you might go, oh, 200 gigabits per second, that's perfectly fine. Not when you're using a high-speed file system, parallel file system, and you've got 20, let's say you've got 28 nodes running, and one of them is misconfigured on his network, so he's not reading as fast as the other ones. Everything else is exactly the same. You know, they've got 256 cores, 2 terabytes of RAM. Yeah, those are like the numbers we're working with. But now he's only getting 200 gigabits per second. All the other ones are getting 400. So when they're reading job information, he's producing slower than the others. So they're waiting for him. So your jobs aren't happening as fast as they should. That can be a problem. But all that to say, right? All that stuff sounds really cool and technical. All that to say, it's a simple command to go see something's wrong with that box, right? Because, well, one, you know something's wrong with the box because you're not getting the performance you expect. But we need these super simple, like, I don't like calling things like stupid simple, but it's almost like simple that there's these few commands that can check so much for us in this world. So, you know, I tell you guys all the time, when you're just looking at a black screen with, you know, green or white letters like this is really daunting for a lot of people. But the things that I do to check servers out and align myself in like an OTA loop to know what's kind of going on in the system, I can just do these simple little commands to see what's going on. Right? So there's that. Now, what is our system doing with the TCP IP stack that it's dealing with? So a little bit of background for people. If you don't know, I'm a networking instructor for college. I've been doing that for almost 18 years. I also teach cybersecurity. I teach all kinds of stuff, right? TCP IP has, so when you're looking at the TCP IP stack, at layer 4, which is the transport layer, you've got two protocols, transmission control protocol and the user datagram protocol, or datagram, whatever you want to call it. And those each have 0 to 65,535, so 2 to the power of 16 total ports that can be connected to or listened to on a system, right? So, well, what that is then is how a server is listening or being able to be connected to in an environment. So netstat is the older way that we used to do it, and netstat's not even on most systems anymore. It is on RHEL and Rocky, but I don't really use netstat anymore. But you can use the same descriptors. SS is the one that I use much more often now, right? And there's all kinds of stuff going on in my system, but I don't want to see all of this. What I want to see here, I'm gonna give some filters. So ss-ntulp, and let's go look. Let's just look at what we need here. So TU are going to be our TCP and our UDP connections, right? So there's our TCP connections, and oh, I thought it was. There's our TCP. Huh? Yeah. Okay. And then right. Well, let's take off the. I'm surprised I don't see the UDP there. Maybe I've got my things wrong. Over here, I want to show you guys something here. It is automatically taking the port number and translating it over into the service name via the file etc services. So it's looking up in etc services for that file. So I can force it not to do that. So I want to see the numerical output for this. And now instead of seeing SSH, I see port 22. And that mapping is right here. So grep 22, well, let's grep SSH from etc services. And here is port 22. So that's where that mapping came from right here, right? In case you guys are wondering. And we could validate that. We can copy etc services to a file called etc services .original. And we can even give today's date, right? Something like that. And then if we ls-l on etc services, we would see that, there's one from when it was originally made and then one that's an exact copy of it right now from today's date, 0404. So let's vi etc services. Let's go down to SSH, and we're going to modify this SSH right here to be, let's be something silly like stream example. And then right here, we're also going to do it for UDP, stream example, just for fun. And then we're going to do that same thing that we just did. We're going to do our ss-nt. It's still the same port number, but we're going to take off the numerical forcing, and look, it's back, and now it's that stream example. That wasn't in that file before. So I just want you guys to see etc services is, it's a human mapping. It's for us, right? It's just the outputs for us to see very quickly, but it's a mapping that's down in etc services by default. So you can modify that if you want to. I wouldn't advise it, but you could. All right, so let's go ss-nt. We'll add the U back now, and then we'll add L, and then we'll add P. So L is where we're going to get UDP traffic in now. So we see that we're listening on that. And then we're going to do P. I thought P forced, yeah, P shows the process IDs. So this is the way that I like to use it, NTULP. Guys, I've seen that as Tulpin, TULPN. I've seen that a million different ways. And at the end of the day, I don't actually care how you want to see that. You can do that almost any way you want. Let me move that over a little bit. Yeah, there you go. So now that all fits on one screen. Also, VLAN X said with sudo it even outputs the process name on that port. Oh well, your root, disregard that. Yeah, I'm always in my home lab. You guys will see me run around as root pretty much all the time. I don't. It's wild west for me in the home lab. I do whatever I want. I'm like Cartman. I do what I want. If you guys aren't familiar with that episode, it's pretty funny. But there's a bunch of information here that SS. Oh, you know what? I need to add one. I need to add one that's actually very, very valuable here. So let me actually. I'll pull this up. I want to add this right here. I'm going to use LSOF as well, because I think LSOF is just super useful for this. So let's go dig in. So we see that we're listening to, so this is the designator for any. We're listening to any address coming in. The 0.0.0.0 is all addresses coming in on port 22. So if you want to come in and connect to my server, TCP port 22, you can do so, and you will be handled by the SSH daemon. So SSH daemon is running on my box. Its process ID is 832, and its file descriptor here is 3. So let's go systemctl status sshd, right? Yeah, we can just do sshd. And we can see it's active and running, and we can see that its main PID is 832. That's the main process ID, 832 right there. So we see that. We also see Well, we don't see it here, but we know that it was started by System D because it's here. If I were to look at this a different way, PSEF grep for SSHD in my system, I would see that 832 right there, and his parent ID. So this is the process ID of a process, so SSHD that was started here. His parent is 1. Guys, 1 is always System D in modern Linux. So if I didn't know any of this other stuff and I just looked here and saw that this port was running on my system, so if I just came here and did an SSNTULP and I saw that port 22 was being run by PID 832, process ID 832, and I went and looked up that process ID and I saw it right here, he has a parent of 1, I would immediately know that System D started that process. Because System D is the controller, he'll always have the process ID of 1 in modern Linux. Well, why is that important? Well, now I know that it's a system service and I can go look around, and I already knew, we knew it was a system service, but if I didn't, that's another way I would be able to indicate this was started when the system came up. So this isn't necessarily we're not going to dig too much into this, but I will show you guys a couple of other things that are useful here. If I see that it's process ID 832 and port 22, there's a couple of things I can dig in on. So LSOF is normally useful for stuff like this. If I said LSOF in the directory I'm in, right? Well, here, the directory I'm in, it would show me that in the directory I'm in, there, I would see that my bash shell that I'm in, this process ID, is actually in the working directory that I'm in, right? And if you guys say, how do you know that's your bash shell? There you go. That's my bash shell right there in the directory I'm in, which makes sense because I'm kind of standing logically in the directory etc sysconfig network-scripts. That is where my bash is holding open and using that directory. So I can't unmount this directory. I can't mount something over it right now. Well, you could mount something over it, but you can't unmount it right now because I'm kind of standing in it. It's like that idea you can't make a bed when you're in it, which, I don't know, some of you are probably athletic enough to do it, but I remember when I was a kid, my mom always said, you can't make a bed when you're in it, and I'd try with like a fitted sheet, and you can't do it. It's not easy. But you could try it if you want. There's probably somebody athletic enough to do it, but you'd probably have to like bounce up and pull the last corner over. Anyways, it doesn't matter. The point is, I'm showing you guys this. This is the network. So what I wanted to show you guys is we know the process right here. We know the process is 832, right? Where's my, and here's my SSHD. Oh, and you might say, Scott, why is it there twice? Why is it there twice? It's the same process ID but different file descriptors. But look, this is the denotation of IPv4 any, and this is the denotation of IPv6 any. So this is the listening. I am listening for IPv6 traffic to come in, and they can establish SSH connections with this if we were able to route back out to them, which we can't in my lab. But if we wanted to, we could. Oh, I got jokes this morning, Paul. Oh yeah, I got all kinds of jokes. I think I'm the funniest guy around, but everybody else is like, this guy's just a straight man, right? Like I was saying, like with Frasier, where you everybody, like, my jokes sneak up on people because they're like, this guy's talking super serious, and no, he was joking the whole time. Yeah, I know. I'll keep my tight 5 for the comedy club. I'm not gonna. I'm just kidding. I'm never gonna do comedy. But all right, so we got all this. Let's check a couple of things now. We look at the values I know. I know it's listening on port 22, so I can say LSOF-I port 22, and I can see everything that's holding open that listener for port 22. I can even see the connections that are coming in from these other servers. So I have a connection from 246. Yeah, for Rocky. Oh, look, and we got that bullshit because we didn't fix our etc services. So our services show stream examples. So I gotta go fix that. So I'm gonna copy etc services dot original back over etc services. I'm just gonna fix it in one fell swoop, and then I'm gonna. Oh. Why are you asking me questions? And then now I'm gonna rerun it, and now it'll be back to SSH instead of stream example. Yeah, that was stupid. I just did that to show you guys. And then here's my connection in from this. Also, Yeah, why does Rocky 4 have a connection directly from my 246 box? That's not common. Yeah, it doesn't matter to me, but that's how we could do these things. All right, let me show you guys another thing. So LSOF, I could also use the port number, the process ID, and the process ID is 832. And now this is what the process is using. So SSHD is touching all of these libraries, right? Here's all these libraries here, and then here's the connection holding, that was file descriptor 3 for, this is my IPv4, and then here's file descriptor 4, IPv6. And you say, Scott, you're just saying that because it says it right there. Yeah, but hold on, it shows it right here. That same information comes right here. So IPv4 is file descriptor 3, right there, and IPv6 is file descriptor 4 right there. So that's how it's holding open and ready to accept a connection in to be able to listen to that. So if anything's ever busted there, you can go look to make sure there's no conflicts or whatever. Libraries that are available in libraries here, this is less interesting for us right now, but did you guys notice when I said system CTL status SSHD earlier, I saw that. Oh man, sorry guys, I had to sneeze. I saw that user sbin SSHD is what was called to start the server, and then there were some values and whatever that were given. But I can do this, watch. I can say LDD user sbin SSHD, and here's all the libraries that this needs to operate. So LDD will show you the libraries that user bin SSHD needs. Now hold on. This is what it thinks it needs as an executable. Here's what it's actually holding open and using right now. They're pretty close to the same things. And if it ever tried to start and these libraries weren't there, it would break all over the place because there's always checks. But if something was wrong, or if this won't happen to you in probably in your career, but you're running service daemon right here. So this one running on port 832 already has these loaded. But what could happen is somebody upgrades the Linux box here, right? And your version of SSHD is still looking at the older libraries, and this will happen actually in Red Hat boxes. You might not have it. We can see if the system needs to restart. If it's been updated before. That's funny. There's so much, man, there's so much Perl involved with need restart. Let's say need restart on this box, and it'll go look and it'll tell us if we've updated libraries and other things. But my point is, and this probably never come up. This does come up sometimes in the world. Honestly, on most systems, if it's just like users logging in, we'd send them a message and be like, hey, we need to reboot this box, and then it'll come up clean. But there's a possibility that you've got like a mismatch between what the original process was that was started and some update that's happened because you've not rebooted your server. So that can come up. Missing packages can break things as well, yeah. And I'm not necessarily going to go deep into package management and that kind of stuff now. That's a discipline that I think is valuable. By the way, some of you guys are probably like, oh man, Scott, this is useful stuff, but like I don't have time for it now, or I want to look this up later. We have LAC. We have a whole bunch of free stuff out there. The guys put together these really good books for you guys, and these books are here for Linux admin stuff. So if you need to learn about Linux administration, maybe you've been doing Linux, but you need the admin stuff to get into the industry. That's what all this is. It's like what the job looks like. If you want to talk about building secure Linux, this is a course that we put together. And then if you want to do our Linux automation course, which is actually just done now, but I got to add a few more labs to it, that's all here. So this is all free. This is all online. You guys can take any of that stuff you want. Yeah, and then look, I can restart services. And no. This thing's asking me to restart all kinds of crap. But now that we've updated things, it says these things all need to be restarted. It wants to restart all these things because of libraries that have been updated, right? And then there's some old session that's running outdated binaries. So again, this is why often we just patch things and then boot them, especially if you need to go to a new kernel, which is outside the scope of this, but typically uname -r, check the kernel version, and then there's a nice little grubby tool. Oh wait, we might not have it. DNF install -y. If you don't have grubby, grubby's great. But grubby will go look grubby default kernel, and well, there's no file. It's because these are stateless nodes. But grubby will tell you if your system wants to boot to a new version, which is kind of nice. All right. So anyway, so this was commands to view networking state. We really kind of went. I'll go far afield if I'm at the command line, but I want you guys to see that this stuff. Look at the end of the day. I know I've been showing you guys a lot of stuff. We have done some very simple walking around and looking at system stuff. We have done some very simple commands to gather what's going on inside of our systems. This is what we want to do. If we want to be good admins and good tracking and fixing of things, because that's one of the main admin skills, get servers back running, we have to have this basic stuff under control. Okay, let's go over to commands to test the network as it is. So I'm on a box, I'm on Rocky, and I want to ping out. Ping is the packet internetworking groper, and I want to ping somewhere, and I need to know its name. So maybe I can use its IP address as well, but I don't know the IP address for Google, but I can go www.google.com, right? And in that case, this actually tells me all kinds of stuff that I needed to know for the system. So I gave it a short name here, www.google, and my system went out on port 53. Port 53 is the default for DNS, and asked the internet. Actually, it kept asking higher and higher servers until it found the one that was going to respond. But we have it only configured to use 8.8.8.8, and I'll show you that. And that one responded and said, hey, I know who Google is. Use this IP address. And then Ping, the packet internetworking groper, used the IP address in a network packet to send it over there. That's what it did. Hold on. Ash updated Nekar said, hey, advise to get into kernel dev eBPF by building your own into Linux. Which would you recommend? A couple things, Ash. Kernel development stuff is awesome. If you're trying to get into eBPF, the best person I know for that, or the best place I know to start for that, is back over here. It's a guy named Brendan Gregg, and he has some stuff on that, so I'll link this over to you so you have it. But that's going to help answer a few other questions here. Our guys in the Discord are going through a thing called Linux from Scratch. Linux from Scratch is a free ebook that's out there, and one of these guys put it together. Let's see if I can find it. And they have everything about this here. So this is the guys are actually going through this on Discord right here. But let me explain something real quick, because hopefully this will be useful for you guys. In the Linux world, if you're going to do admin engineering architecture for an enterprise, well, let me back up a second. If you're doing it for fun and for profit and whatever in your own home lab or for your own interest, do any of that stuff you want, like building kernels out, rebuilding your own OSs. Those are all fun things to do. And we have some guys down the Discord doing stuff like that. If you're doing it professionally, it's not like that. In the professional world, we typically have a service contract with RHEL or Ubuntu Canonical, or even like SUSE, right? SLES, which is SUSE Linux Enterprise Server. We have a contract with these companies, and now we can't muck around with the kernel. It would be like if you had a fleet of Chevys and you dropped your own little bullshit engine in there, and then you're like, well, I need you guys to fix it. They'd be like, oh, we don't touch that engine. We touched the original Chevy engine, and you voided all the warranties when you did that. Well, it's the same way in the Linux world. So where I'm going with that is when I talk like fun hobby stuff, we can do all that stuff. But when I talk like stuff to get you guys in the industry, which is kind of what I'm focusing on now, I tell you, it kind of sucks, guys, but think of it like this. Like in the Linux world, our goal is to build stable boxes for a company to have developers on and whatever. We are basically making the most vanilla servers ever. And you're like, but I'm a master. I could build these snow cones that would make you cry, or ice cream. I could make ice cream confection that'll make you cry to even look at it. It's so beautiful. And I go, Yeah, but most people just want a fucking vanilla ice cream cone. Anyway, so where I'm going with that is all those things are awesome. All those things are great. Guys get down to it in Discord, hobbyist type stuff on that. Most of this stuff, I'm pretty much just showing you guys like stuff for the industry, which unfortunately in the industry, if we go mucking around with our own kernels, you void all the warranties and now you get no more support on it and this and this and this. And the it's the same thing with mucking around with TCP IP. In high performance compute, we will change TCP IP settings. However, we now know that we own it. We know that once we change off of like a system baseline, we have to keep track of that. We have to, anyways, where I'm going with that is like, I kind of showed you where I would go look for those kind of things, but there's that. What'd you ask? Oh, the optional period at the end of domain? Probably just in case they were placeholding for a higher domain hierarchy, because it's all DNS is all hierarchy. I don't know that right off the watchmakering. I'm not sure. The optional period at the end, I'm not quite sure on that for sure. So anyways, all right, so let's go back to this real quick. So this server did something and it resolved this name to an IP address, and then the system spoke to each other over that IP address. So let's validate that real quick. Let's go do a host on www.google.com. This is one of our tools that exists. And that'll give me a bunch of name resolution, both for IPv4 and IPv6. Now, I told you guys IPv6 routing isn't working in the lab on purpose, but we could set it up and work with it. I just turned it off so we didn't have any weird traffic to monitor. We're basically just using IPv4 traffic. But we could use host. We can use NSLOOKUP of that same thing. And this will give me a little more information. Specifically, it'll tell me the server that's in my etsyresolve.conf file and the port that I used, which was 53, to get out there. So cat etsyresolve.conf, and that is the file, that is the name server, and we can have multiple name servers that we want to use. In fact, in a lot of homes, like I could have 192.168.11.1 in there first, using a local DNS cache, and then only go out to the Google. This is Google's open DNS for anybody to use, only if I needed to. But by the way, here's my non-authoritative answers that look pretty similar to my host answers. They should be pretty much the same. But that's how we're going to get over to Google. Then the last one I might use is dig. So I might dig www.google.com, and you're going to see a slight bit more information. You're going to see the time it took to give me an answer, and then this one only gives me my A records. A records are always IPv4. Quad A, which is 4A records, would be my IPv6 records. So I might have to dig, I think it's dig -6. Somebody might know this better than me. If I wanted those one, I think it's -6. I might be wrong. We can look it up if we need. It'll give me only quad A records, but let's see. I don't know. I don't use IPv6 very much. All right. Let's see if I can fix that command. Sometimes you get help in here. Q class. Should be. We tried class. Do you mean for it to be a link? It was Oxide. Oh, yeah, Ash. I haven't really used. I don't really do a lot of. You'll find, like I tell people, I'm very vanilla in my engineering. Most of the stuff you'll see me do is build Linux systems out. I will harden them for like STIGs. I'll use like Ansible for that, and then I will make sure that everything in my environment works with whatever specific HPC standards I'm going for. But you'll find that a lot of my stuff is very vanilla. But it's because that's like what a lot of the industry is. Like, it's like, hey man, all of us want to go work on like the NASCAR fastest cars out there, but a lot of times we end up just working in a normal garage fixing Toyota Priuses or whatever. It's like that because that pays the bills or whatever. Well, a lot of the stuff that we do in the Linux space, we're just keeping servers running for a company, and then we have to do all our fun stuff on our own time or whatever. So something to think about. Yeah, I don't know. Maybe it's just 6. It might not be a dash. Maybe it's just 6. Yeah, there it is. No, that still give us. I don't know. I don't use dig that much to do that. But anyway, so this will tell us information to resolve things that I can't remember, because I can't remember all this other stuff. So I can also do Yahoo. Let's go Yahoo. Yahoo, and there's Yahoo, and I like to use Yahoo because once I start doing weird packet stuff to Google, it won't respond, but Yahoo still will. And I'm going to show you guys some weird packet stuff here in a second. But anyway, so I can see that there's a bunch of things that I can tell here. If my system can ping if you go to a server that's not working right and you had to SSH in, first off, if you SSH in, IP address is still good, SSH is still running, so that's good. That's up to the networking layer. When you ping somewhere out from that server, you see that DNS is working, so DNS is resolving this to this, so that's happening. If your DNS resolver is local, that doesn't necessarily tell you anything, but if I knew that this had resolved all the way out to 8.8.8.8, now I know that I'm routing all the way out of the system, so that's useful. But let's say this wasn't working. So what might I do next? Well, I start to do a set of hops from my server further out to see what's going on. So I'll do my IPR from earlier, and I'll see that my default route that I was going to take to get there is 192.168.200.1. So I'll ping C1 192.168.200.1, and I'll make sure that I can get that next hop. Okay, I can get to my gateway. Me and my gateway are talking. I'm on a network. I'm correctly doing the networking things that I need to behave in here. Okay, then maybe I know that the next network hop, maybe I just know this from being in my network, is 11. So my next network hop that goes out is 11. So can I ping that? Yes, I can ping that. Okay. Then maybe I say, well, I just want to ping out to anywhere else, right? Like anywhere else in the world. And maybe I see that. But again, this is why I ping Google first, is because if I can ping to it, then I don't have to do all these individual checks. This was just like next hop checks to see if things are there. But a lot of stuff, this stuff will be broken. Something will not be happening, or that route won't be right, or your device won't, be doing whatever. So then maybe we have to check. There's other things that we can kind of check in there, but for me, I would go start digging in, make sure that my network connection is like I expect. Okay, I see that I'm on the network. I might try to ping different devices in my network. Like I might know that 192.168.200.51 is the Rocky 1 server, so I might be able to ping him. Okay, I can still talk to people in my network. But if I couldn't ping over there, maybe I need to make sure, maybe is my device up, right? So there's all kinds of things that go back to those original things that kind of tell us like, hey, if I can't reach out and do ping, there may be other problems in my network. Okay. Now I'm going to show you guys one that I think is really fun, because I think this is great to show people. If I do IP adder on my box, I see that my Ethernet has a maximum transmission unit of 1500, right? Yeah. So if I were somebody that did, let's see if I can't find this. Let me see if I have my little networking primer. Just pull up the PowerPoint real quick. Let's just see if I have my, more presentations. I know I have my networking primer. All right. So networking primer looks like this. This is one this is all recorded, so if anybody needs this one exists out there in the world. I want to show you guys something real quick, and I'm not in network engineering mode right now for you guys, but if you guys want that sometime, the OSI model works like this, and I'm just going to give this quick hierarchy to show you guys. From the network layer, packets are dropped down into the data link layer. There's a header applied and a trailer applied, right? But the maximum transmission unit of an Ethernet 2 frame, we mentioned this earlier, in my network is 1500. How do I know that? It's 1500 right there. Do you guys see that? So what that means is, as the data are flowing down and they get turned into a packet, and network layer is where ICMP exists, so ICMP is going to be inside of this packet with a header applied on the front of it. This has to fit down into that frame. And that frame from header to the end of the trailer is 1500 bytes. Is everybody tracking on that? Right? Like these things are moving down and they're going into packages, and they get down between the network and data link layer. And you say, wait a minute, Scott, I send more traffic than that all the time. And I say, I'm sure you do. So what happens here is if a packet's too big, it gets chopped and put into two, if you want to think of these as 1500 byte rail cars, it gets chopped in half and it gets into two of them, and then it can still go and come back. Now, I'm going to prove this to you here in a second, but we can say at the network layer, this is a, anybody here ever seen a Christmas Story? This is a major award, and it's fragile. You can't cut it. You can't cut this packet. As this packet flows down, and it's over 1500 bytes, well, actually like 1472 or something, we're going to say you can't fit it in here. You're not allowed to cut it. And what the data link layer is going to say, I can't send it. This is going to break all over the place. So we can prove that, right? We can validate that our traffic flowing from one to another is like this. So watch. And we see that it's 1500 right here, right? So let's go out to Yahoo real quick. Let's ping yahoo.com. Boom, we got to Yahoo. So now we're going to muck around with it a little bit. And we're going to say -C1 so it only does one, because otherwise ping will go forever. I'm hitting Control-C to stop it. But now I can say -M do set the don't fragment bit, and that will go as well. It'll work, it's fine. And the size of the packet is actually pretty small. Look, that's the whole thing. So now let's make it bigger. We can make this packet bigger. We can make it -S size of, let's make it 1500 bytes. Let's make it to start 1400. Okay, and it says, yep, I made it. I got one packet went over there and whatever. And then now here we're gonna make it 1500 bytes. And oh, hold on. We're gonna just do it like this without the permutation on it set to do. And that's gonna go ahead and send one packet, but it was broken into 2 frames, and then it got over there and it came back. And you say, Scott, can you prove it was set? Now I'm gonna say, don't chop that packet. So don't chop the packet. It's gonna break. I couldn't send it because I tried to follow your rules of not separating this packet out into 2 frames, but I couldn't do it because it doesn't fit in the 1 frame, so I broke. And some of you are going to go, Scott, that seems like a really niche. I've had to use that twice in my career. So I had storage, but the storage was in a different part of my facility, and I had a couple of high-speed switches in between. I didn't control the high-speed switches, my networking team did. And my networking team assured me that I had 9,000 byte instead of 1500 bytes. I had jumbo frames set the whole path. I said, okay, I'm not getting the speeds that I expect with this storage. I think something's wrong. So what I did was I pinged the storage, and then I set my MTU to just walk up. I did this right here. I'll show you guys. This is going to become $I. And I went like this in my cluster, or in my little area. I said for I in, and then I just kept a sequence here. And I said, we'll start at 1400, and then every 20, let's say, up to 1600, I'm going to do a ping up to there, and then I'm going to say done, right? So this is going to walk the ping. Oh, we can even sleep 1, so it doesn't go too fast. Now, this is going to walk my pings up, and halfway through, it's going to break all over the place. So pinging, 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 pinging. Oh, message too long. Message too long. I don't have a 1500 byte. I don't have a 9000 byte in my case all the way through my path, but I don't control those guys. I need you to check them, and they would go fix it. Yeah, so maximum transmission unit is the same even in VLANs. It's just the size of what's allowed to fit down in there. So going back here, as the packet comes down, that packet is either, basically I can either come like Fruit Ninja. Do you guys remember Fruit Ninja? I can either chop this packet up or I can't. That's what that permutation -M do is setting the do not fragment bit. If it's set like that, it won't even try to send it. It'll just tell you the maximum transmission unit's too long, because the data link layer has a hard set 1500. So you might say, well, could we find the exact one? Yeah, we could find exactly what it is. We could just go here. I want to say it's like 1472 will still work, but then like 1474 is too long. So 1472 is like the max with the header and the footer put on that frame. for us to send things. And you might say, Scott, what? I'm never going to see that. And you're like, you'll never see that. You'll never see that unless you hard set that. However, fragmenting packets is a study. For those of you that are like, because I just had somebody, I was given an interview yesterday, actually, for my company Redline, and we had somebody in, and he told us, like, hey, I'm being full disclosure, I kind of want to go red team stuff. And what happens in red team is we fragment packets so that they get reassembled on the other side of firewalls. There's a whole discipline in that. So if you guys want to go look into bypassing firewalls with fragmentation of packets and stuff, because they're looking for certain signatures and other stuff, and if we fragment our packets down and get them reassembled on the far host, they can bypass firewalls. So there's a whole cat and mouse game with that if that's something interesting to you, right? Not super interesting to me. I did my red team time in my career, and I'm not really, I don't need to do that. I just like engineering. So but that's something that's super interesting to people, so you can go dig into how that works, and you can go squirrel around with bypassing firewalls. That's called fragmentation, packet fragmentation to bypass firewalls. There's all kinds of stuff on that. Yeah, so Avamar Smith, what happens on VLANs? So let me explain VLANs real quick. Switches, VLANs only work if switches behave. So let me come down here. So this is, I have an old talk on this, but layer 2, your frame looks like this, right? This is what a frame looks like directly from the standard. And where's the standard? I have it here somewhere. But what happens is we put an 802.1q tag in there. So this is what a standard header looks like, and we drop an 802 frame, 802.1q frame right here. And I can show you here real quick. So an 802.1q frame, you can just go look it up. But all it does is add right here after the source address but before the type. So right after the source address but before the type, it adds a little 4-byte 32-bit VLAN tag in there, right? And what happens then is on most unmanaged switches, they just ignore it. They don't even care that you did it. But on managed switches and switches that are what we call VLAN aware, they care very much. And in my home lab, my devices care very much about this as well. And the only thing that causes a VLAN to matter is that a switch won't forward a frame out of an interface that's tagged to a VLAN if the VLAN tag doesn't match the frame. Or if the VLAN tag doesn't match the VLAN that's set on the port for the switch. It doesn't allow it to egress. It'll come into the switch, but it won't egress out the port for the switch if the VLAN tags don't match. Now, there's 2 modes for switches. There's a few other ones, but I mean 2 that mainly come up. Switch port access mode, so you can have access, and that's typically only going to be 1, but sometimes we allow 2 because of data and voice for end nodes. And then there's trunking. So trunking allows us to extend VLAN ranges between switches, and instead of configuring all that by hand anymore, almost universally in the networking space, we turn on a thing called virtual trunking protocol. And virtual trunking protocol makes all of the switches pass that trunking information themselves. And the way I explain it to people is like, if I had 2 puddles of water here, like when you were a kid, did you ever like fill up kind of dig a little hole and put some water in each? Well, if you had VLAN 1, 2, and 3 over here and VLAN 1, 2, and 3 over here, they would be separate VLANs. They would not be the same. But then if you trunk between them, so if you ever like dug your foot in the dirt and then the water's connected, now VLANs 1, 2, and 3 are the same on both sides. So I know it's a weird way to think of it, but trunking basically makes everything the same. Otherwise, disparate VLANs are completely different in your system. And that really only comes up, that's more like advanced networking stuff. That's less important for us on the system side. Today was mostly system stuff. But I wanted to show you guys, yeah, that's where that frame gets dropped in there. And we can then see that if we either do a TCP dump on a system, right? So we can TCP dump everything, throw that into a PCAP filter, pull it up in like a Wireshark, and we can see if VLANs are tagged. Most of my stuff in my home lab doesn't have VLAN tagging in it. So I can come here. I do have VLAN tagging for my Rocky system. Let's go look at this guy. So cessation frame. Does he have VLAN on him? I don't see VLAN in here. But the Rocky servers definitely should. Yeah, I don't see any VLAN information here. But it could just be where we're at. Let me go look at something that's going to leave. Well, it could also be by the time I got a hold of it over here. VLAN would be right in here. It would be right between source and type. Oh, there's a tag in there. There's a missing tag right here. Where's that at? There is... Why is that not showing up? That's weird that that's not indexed. There's... Oh, there it is. Okay, source is there. Alright, that's what it was. Alright. I don't know why that wasn't shown. Alright, it doesn't matter. Point is, yeah, that's how VLANs work. Clear as mud, right? Anyway, so then now the next one that's useful is mapping your address resolution protocol. That's ARP. And ARP will show you if something is local, we just talk to it directly via its hardware address. So these are the local devices here and the hardware devices that I can see. Now I can ping 192.168.11.1 and we know where that is in my network. And then I can do ARP again and I still won't see his MAC address because he's a hop away. We had to go past my gateway device, gateway device's C router, and the frame was stripped off at C router and a new frame was generated on the other side. And the 192.168.11.1, I'll never see on this side of this network, I'll never see his MAC address because it doesn't make it over here. So just remember that, guys. MAC addresses don't leave networks. That's something that like crime shows say to be funny. But I'm thinking the analogy best to be STH and VPCs with private links. You really need to get down to layers of abstraction. Yeah. ARP exists on a table on any device, router. Yeah. So switches build ARP tables, what they call MAC address tables. But yeah, all of your devices keep track of address resolution protocol for things that they can see. And they map them back to, this is IP addresses right here. But in my system, that's map. So by default, it doesn't give you the actual IP address. But that's these are all mapped from my Etsy host file. Well, gateway is that's keywords that's been found. But there's my gateway. We know that from IPR. We knew that was my gateway. But that's how we could validate it right there. If you want to see, does my ARP know the gateway and what's the MAC address for my gateway? Right there. And then when I'm looking at my PCAP filters or whatever, I could validate that that's who I'm talking to when I talk to the gateway. So there's all kinds of, guys, there's all kinds of like this goes real deep. I was even showing my college students the other day, which, by the way, I do have to get off of here soon because I got to go talk to my college students. But for, what was I thinking? For my college students, I was showing them that there are, like within Wireshark, if you want to go deep on the networking side of things, Wireshark actually has a certification now. And you could go study up and get really good at Wireshark if you wanted to, I don't know, put something on your, if you don't have anything on your resume and you guys are trying to get into the field, that's an excellent thing to start with, right? DeVry, Ash asked what college I teach. I've been at DeVry for 10 years now, and then I was at a school back in the day called ITT Tech, which doesn't exist anymore for other reasons than the teaching, more for the amount of federal loans they were letting students take. That was a problem. But I didn't have anything to do with that. I was just on the teaching side of things. So we got down to ARP. Then we can look at, so we wanted to see, again, how the network is behaving for us. So SAR-N, and SAR, by the way, so we might say DNF, what provides SAR, and C, that SAR comes from the sysstat package, right? So SAR, so I might say which SAR, and I see that it's in user bin SAR. And if I wanted to know the permissions, user bin SAR, I can see that SAR is executable by anybody on the system. So anybody can execute SAR. So SAR-N dev will show me, and I'm going to do 1, so every 1 second, show me how the devices in the system are behaving. How much traffic is being received. RX is always received, guys. So here's my received packets. Here's my transmitted packets. Here's my received kilobytes, right? Capital B is bytes, lowercase b is bits. Transmitted kilobytes per second. Here's my received, I don't even know what CMPs are, or transmitted CMPs are, and then received CMS, so MCSTs, and then if util. So all we're seeing here is transmitted packets and received bytes. So am I getting, now some of you might say, well, oh, this is cool, I can see if I'm using all of the system, this and this. This is just a utilization value. This is a 0 to however much it can go up to, and this is useful to see that we're not redlining anything. Nothing's going too high, nothing's going too low. If I expected a bunch of traffic on this loopback interface and I'm not seeing it, well, that's a problem. Maybe that other interface isn't correct. Well, loopbacks are just loopbacks, but let's say I had multiple Ethernet interfaces in different networks and I'm not seeing traffic go a different way. I know my backup's not happening on the server, whatever, right? But the point is you can see what's going on here. Another one, instead of just the device, you can do TCP connections. So maybe this is a web server and I need to see how many TCP connections I have into the system. How many are active and passive, and then how many segments are coming in. And so inbound and outbound segments, right? Because at layer 4, it's segments, right? So we are getting TCP traffic in and out of the system, all right? But then maybe I want to see errors of TCP, so eTCP. I can see errors that are happening. Maybe one of my web servers is not properly responding for TLS traffic, and I need to see what's going on there. Well, I'm not getting any errors in that space. So that is something that is now exonerated at that level. I can go look somewhere else in my system. So ICMP is Internet Control Message Protocol. That's what ICMP is, Internet Control Message Protocol. I pulled up earlier. Hold on. Where was that at? Oh, it's here. This was Linux from scratch. We were talking about Linux performance. ICMP. Wikipedia. I pulled this up earlier for you guys to look at if you were like, hey, I need to dig in and understand the different types of responses and traffic for ICMP. Yeah, that's what ICMP is. Internet Control Messaging Protocol. Not to be mistaken with ICP, which is the Insane Clown Posse, which was a band that was popular in like the 90s. I think maybe even into the early 2000s. They were part of that Juggalo, which were just clown people or something. I don't know that culture at all. Anyways, SAR will give us a bunch of information about just what's going on in the system, and it's useful. Now, iPerf is a speed test between two nodes. So if I have iPerf, I don't have iPerf. iPerf 3. I don't have it, but if I did, I would need to have a server running to connect to, and I think it's port 5201. Oops, right over here. DNF -y install iPerf 3. You need to have a server running to connect to, so iPerf 3-S will turn on a server. So now my system is listening on 5201. And if I were to come back over here, and maybe I have iPerf 3 over here. I think I do. Oh, this is an older box. Yum install iPerf. I don't even think this box can get new updates anymore because the repos are all shut down for it. This is an old server here, guys. Yeah, this one's not gonna work. Let's go over to Bastion. We'll go hop on Bastion. Okay. Oops, not 4, 3. There we go. All right. All right. Yeah. So here I'm gonna go iPerf 3. I'm just gonna leave it open. It's gonna say, hey, buddy, if you want to connect over to a server with TCP by default or UDP if you want, let's go ahead and see what kind of speed we might get over to that other node. So it also says we can be the server if we want -S or -C to go to a host. So I say iPerf -C Rocky 4 because that's the one that's actually over there. What? should be right. -c host. Oh, we gotta put the, that's weird. We gotta put the options after. Oh wait, that should be fine. And then, oh well, I guess we can set other values in here if we want as well. Options. Now the port, we can change the port on the listener, but we're just going to connect by default, and we should just be able to go directly over there. -c should just go directly over there. I guess we can give -n streams, right? Yeah, that's fine. Okay. Haven't used the iPerf in a while. Let's go see. Oh, you can also give sizes of things. I shouldn't have to do any of that. Oh, maybe time. No. Let's look for iPerf examples. You only need to see if it defaults. Yeah. I haven't used iPerf in a while. Oh, well, I should be able to run the... Yeah, that should connect. I shouldn't need to give the port, because the port's default. Huh. I don't know, maybe I can't use the... Super weird. Oh, you know, well, yeah, nope, that's right. That's exactly right. I actually have, so... Yeah, I got a firewall on there. Just for now. We'll stop it. Run it. Yeah, that's my bad. Yeah. We should just be able to go right by name now. Yeah, that was my fault. So now it'll do a 10-second test real quick for us, and it'll show us that we're getting some amount of speed that we expect, right? And then I may say, well, that's not the speed I expected, but then I got to understand how I'm getting over there. Rocky 4 is on my Proxmox server there in that network, and then the traffic's got to go over. So there's probably a little more hopping around in my network than I expected, so maybe I'm not getting exactly the bit rate that I expected, right? And then we can go test that. Yeah, that was just because I had my firewall on. I also, by the way, could have listened on a port that my firewall had open, you know, if I had a range open or something. But we don't normally do that for security reasons. But anyways, the point is we could also background that and get that out of the way and stuff. But iPerf will speed test things for you and validate that you're getting the speed as an aggregate that you expect in the system. Yeah, that, I mean, that should have been working, but it was just that I had the firewall off. Firewall. There you go. See it running. All right. The other things that are useful then on a box is I need to see all the traffic that's coming in and out, right? So I need to just like TCP dump everything. But this is not super useful to just TCP dump everything. Typically, we want to use a specific interface like I0 and then just the interface 0. And it'll give us what's going on with the server. And then a lot of times I want to maybe set the size to the maximum allowable for a system for 535, right? We can set the size all the way up. And then maybe I only want a count of like 1,000. So only give me the first 1,000 or whatever, right? And this is okay. I mean, that's a lot of info, and that's probably scrolling too fast for any of us to really care. But what might be useful here with TCP dump is that I can pull this out. This will only do 1,000, so it should be almost done. I gotta get off here. I guess a little timer for my college students. I'm gonna give myself 10 more minutes, guys. Then I gotta get off of here. Go talk to my college students. All right, yeah, see, it did 1,000 packets. But what might be more useful is to come over here and do an output to a file, and let's call it temp. Let's call it maybe hostname. So in here we'll say hostname dot pcap dot, and then maybe, or let's say hostname dot pcap can be at the end, and then maybe we'll do something in here like date, and date can be date plus percent f, something like that, right? And then now that's gonna dump all of those. Instead of coming to the screen, they're only gonna go, and after 10 or after 1,000 of them, which there's gonna be a lot less because now it's not sending this traffic here. It's just whatever else is going in and out of there is gonna be captured, and then we're gonna be able to go look at those in a PCAP file if we want. We could open that up in Wireshark. Yeah. That'll take a little bit to finish. But then ngrep is also a super useful little tool. ngrep will allow you to grep, and both of them in the background use a thing called PCAP filter. So I'm gonna let that keep running over there. I'm gonna jump over here, and I'm gonna do a man on PCAP filter for you guys. And PCAP filter looks like this. It will allow you to filter down based on all kinds of values. You can do destination host or source host. So all the traffic that I'm listening to, I only want stuff that's going to a destination host. I only want the traffic that's going to my backup server. I don't want anything else. I just want to see, are we actually sending data to our backup server, in some range. Okay, boom. I only want source host. I only want traffic that's coming from some other host directly to my machine. And you can do that, and then it'll look for that field source, and it'll only get traffic that's coming in from some source host. You could have a specific host. You can have destination or source, and that's Ethernet, so that's based on the MAC address. Not super useful. But what is useful is destination network, so I expect everybody within maybe my marketing team to reach into the server, so I just want to see that all of their traffic's coming in. Or only things from my local network or for a specific network. Oh, by the way, this would be if I was sending traffic out. And then this would be by destination they were sending it in. So there's just, there's all kinds of stuff. Specific ports, you want to listen to only a destination port of 8080. So traffic is coming to me on port 8080, or if I'm talking out to a specific server on port 8080. Destination port is relative to who's sending or receiving, but these filters don't care. They're only looking for destination port to be that. Then source port. Source port is like if I was a web server and I was listening on 443, I would have my source port of 443. I'm not connecting any 443s out, so I don't have to worry about their source ports on traffic coming back. This is only for traffic coming in. So anyways, there's a whole bunch of stuff. You could do port ranges. So typically if we were talking source port range, there's a very common port range that we use in systems to look at all of what we call the ephemeral ports. So 0 to 1020, 0 to 1023 are what are called the well-known ports. And then typically 1024 up to 49.9 something are the other ones. In fact, by the way, we can see it right here. Here are your well-known ports. There's your registered ports. But typically ephemeral ports are anything outside of the well-known port range that a system can use for its client connections when it's allowing source traffic to come back, right? So, yeah, we could check, absolutely VLANX, that would work, yeah. I just had that thing blocked off, so we found it. But TCP dump and ngrep use that filter, so that's kind of an important thing. By the way, look, that finally finished at 1,000. If I did an ls-lh on temp, and it should be temp Rocky with that name pcap. That file is almost a meg in size. It is pcap, so you can't read it. You can't read it like this anyways, right? That's not readable. It's only readable, it's a binary file, right? So it's only readable by pcap tools, but Wireshark loves them. So Wireshark can read that, and we could see all that traffic if we wanted to. All right, then the last one, this is maybe just the last thing before I got to get off of here, but can we connect to a disparate server on some port? So I'm on Rocky 4 here, and I know that Werewolf in my environment right? Werewolf uses port 9873. I see that. So I go to Rocky 4, and I want to talk back to my Werewolf server. So I say NC to the Werewolf server, which is Werewolf. That's spelled correctly for the tool. And I want to use, we could check port 22. Oh, I do. See what provides NC. Oh, nmap ncat. All right. DNF install nmap ncat. And I'll put it on real quick. I'm not used to seeing that at all right there. I don't want to restart any of that. Okay. Probably because I put need restart on there, so now that's extra functionality. Great. Let's go check. Werewolf on port 22 gives me a header, so that's connected. But typically you don't want it hanging like that, so you'll add like -VZ, and that'll just tell me that I connected over, so that's cool. But I should also be able to go 9873, and that's the Werewolf port, right? So I see that Werewolf is listening on that server. Unless you think I'm just messing around, what if I tried to connect to 9873 on Rocky 1, which I know does not have Rocky 1? That's not going to work. But what if I do 22? That connects right over. So you'll get weird messages, but you won't get connections. And NC is the underpinnings of Nmap. So people that scan networks and run Nmap, you're using NC under a wrapper. Nmap just goes and does all those commands individually for you. And then, one that's not really around anymore, but Telnet does the same functionality and it looks pretty much the same. So, but I will tell you, security teams will scream to their high heavens because they're like, Telnet is unencrypted. We can't, the only thing we use it for, we don't connect to servers, we don't connect to switches with it anymore. We only connect to test the connection. But you will almost, if you put Telnet on your servers, you will almost always get pinged by security teams about it. And Nmap is similar because they're like, well, we don't want scanning tools in our network. And you're like, yeah, except the security admins should be able to. So NC tends to fly under the radar, though. So if you just get Netcat on there. Although Netcat came with Nmap in this case. Oh, maybe it didn't. Yeah. Well, so we don't have the Nmap, which is good. Because, yeah, security team will ping you if they've got scanning tools that look for that kind of stuff as well. All right. So real quick, so as everybody knows, the stream goals today, there were 3 things. We talked about system configuration, where all the networking stuff is contained. We talked about commands that can view the state of the box you're on, and then commands that can validate all the networking was working. That was our high-level stream goals today. We did the system configurations. We looked at where they're set. We looked at kernel behavior and ways that you can change the 1,024 kernel parameters that we found. Not all of those are related to networking, but a bunch of them are. We looked at how that falls into like STIGs, Security Technical Implementation Guidelines, and we kind of broke that down. We talked about if Firewall D is on, and then later we broke everything because Firewall D was on. Making sure that firewalls are up in your environment can be important. Then we looked at a bunch of commands that just kind of viewed the network as it is on the system, so that you could then make sure that, I've got my IP address, I got my route, are things working the way that I expect, NMCLI to look at the connection, ETH tool to make sure that we have a established connection there, and then SS, NetStat, or LSOF. Any of those will show you, SS is like system sockets, I think, and NetStat's kind of deprecated, so we almost got to put a little dash there. It's not on all Linux systems anymore. In fact, it's on the Rocky 9.6 boxes, but I don't think NetStat even exists in in Ubuntu at all anymore. Like, I think you have to install that separate if you want it. But SS does most of the stuff you want it to. And then we talked about like reaching out from a system to validate like basically all of our little feelers and make sure that everything was working kind of the way that it was expected to. So, all right. If you guys stuck with me this long, I appreciate you guys coming around. I'm going to drop off of here. I got to go yell at my college students. College students won't yell at themselves, so I got to do it for them. You guys are welcome to hang out in the Discord. There's a link for the Discord there. On the YouTube side, links are in the description. So you guys are welcome to hang out with us. We've got a fair amount of kind of fun stuff hanging out in there. I mean, we've got, they may even be doing the group right now. Let me go check. I think there's my little timer going off. I think the guys are down. No, they're not doing it today. But typically they'll be down here in the voice channels hanging out. But there's a lot of stuff going on. You guys can plug in however you see fit, and there's just kind of the group's for you guys, right? Get better at Linux and get yourself into the field and all that good stuff. So I'm gonna go again, yell at my college students for a little bit. I will see you guys later. Some of you guys I should be on tomorrow, either working on labs or building labs, because labs are for Sundays. Sundays are for labs. So all right, take care, guys.